Imagine floating in complete silence, surrounded by infinite darkness, watching billions of fragments of rock and ice travel at terrifying speeds around a blazing star. This is our solar system, a violent cosmic arena where survival is never guaranteed. Somewhere inside this chaos, a small blue planet struggles to remain alive. Earth is constantly under threat from space debris, asteroids, comets, and fragments left behind from the formation of the solar system. Yet for more than 4 billion years, Earth has survived. Not by luck alone, but because of a giant unseen protector far beyond its orbit. A planet so massive that it reshapes gravity itself. That guardian is Jupiter. To understand how Jupiter protects Earth, we must travel back to the very beginning, to the birth of the solar system 4.6 billion years ago. At that time, the sun did not yet shine as it does today. Instead, a massive cloud of gas and dust collapsed under its own gravity, forming a swirling disk. Inside this disk, microscopic dust grains began colliding and sticking together, slowly forming larger and larger clumps. Over millions of years, these clumps grew into planetesimals and then into planets. But this process was brutal. Collisions were constant. Gigantic impacts shattered worlds before they were fully formed. The region close to the sun was a cosmic battlefield, where survival depended on orbital stability and timing. In the inner solar system, rocky planets like Mercury, Venus, Earth, and Mars struggled to grow under relentless bombardment. Every orbit carried the risk of catastrophic collision. Far beyond this chaos, past the frost line where water and gases could freeze, a different type of planet was forming. Here, icy materials allowed massive planetary cores to grow extremely fast. One of these cores became Jupiter. Within just a few million years, an instant in cosmic time, Jupiter accumulated enormous amounts of gas and ice, ballooning into a giant more than 300 times the mass of Earth. As Jupiter grew, its gravity became overwhelming. It began shaping the architecture of the entire solar system. Its immense pull disturbed the orbits of countless planetesimals, either capturing them, ejecting them, or redirecting them into new paths. This early intervention by Jupiter dramatically reduced the amount of debris that could reach the inner solar system, giving Earth a chance to grow, cool, and stabilize. Without Jupiter, Earth's early history would have been vastly different. Models show that in solar systems lacking a massive gas giant, inner planets experience far higher collision rates. Many never achieve stable orbits. Others are repeatedly sterilized by massive impacts. Jupiter's presence provided gravitational order in what would otherwise have been endless chaos. Even today, Jupiter remains the dominant gravitational force after the Sun. Its massive size bends space itself, influencing objects millions of kilometers away. Asteroids that wander too close experience dramatic changes in their trajectories. Some are pulled in and destroyed. Others are slingshotted outward at enormous speeds, permanently removed from the inner solar system. This gravitational slingshot is one of Jupiter's most powerful defensive mechanisms. When an asteroid or comet passes near Jupiter, it enters a region of intense gravitational distortion. Depending on the angle and speed of approach, the object may lose energy and fall into Jupiter, or gain energy and be hurled into deep space. In both cases, Earth is spared. Between Mars and Jupiter lies the asteroid belt, a region containing millions of rocky fragments. These are leftovers from planetary formation, prevented from forming a planet due to Jupiter's gravitational interference. Jupiter's gravity creates resonances inside this belt, areas where orbital stability is impossible. Asteroids entering these regions are gradually pushed into new orbits, many of which lead them away from Earth entirely. Some asteroids are sent inward, but statistical modeling shows that Jupiter eliminates far more threats than it creates. Without Jupiter, the asteroid belt would contain far more mass, and Earth would face relentless bombardment. Life, as we know it, may never have emerged. A dramatic demonstration of Jupiter's protective power occurred in 1994, when comet Shoemaker Levy 9 slammed into the giant planet. Years earlier, this comet had wandered too close to Jupiter. Tidal forces tore it into more than 20 fragments, stretching it into a long cosmic chain. Over the course of several days, these fragments crashed into Jupiter's atmosphere, releasing energy equivalent to millions of nuclear bombs. The impact scars were larger than Earth itself. They remained visible for months, reminding humanity of the enormous threats constantly traveling through space, and of Jupiter's role in intercepting them. Had Shoemaker Levy 9 continued its journey unaltered, its orbit might eventually have crossed Earth's path. The result could have been global catastrophe. Instead, Jupiter absorbed the impact, sparing the inner planets. Beyond the asteroid belt lie the icy realms of the Kuiper Belt and the distant Oort cloud. These regions contain trillions of frozen bodies, comets that can be sent hurtling toward the sun by passing stars or galactic tidal forces. Many of these long-period comets encounter Jupiter first. Its gravity captures, redirects, or ejects them, dramatically reducing the number that reach Earth. Jupiter's gravitational shield is so effective that simulations show Earth's impact rate is reduced by at least 10 times, and in some models, up to 100 times. This difference marks the boundary between a world capable of supporting complex life and one doomed to constant extinction. As Earth slowly cooled and oceans formed, Jupiter continued to patrol the outer solar system. Over billions of years, it absorbed countless impacts that would otherwise have threatened Earth's fragile biosphere. Life evolved, diversified, and spread across the planet, protected by a giant world that few humans ever consider. This silent guardianship continues today. Every year, Jupiter intercepts or deflects objects large enough to destroy cities, continents, or even entire ecosystems. And this is only the beginning of the story. Now imagine drifting farther away from the sun, crossing the orbit of Mars, entering a vast region filled with millions of rocky bodies. This is the asteroid belt, a colossal graveyard of failed planets, shaped almost entirely by the gravity of Jupiter. Every object here tells a story of violence, destruction, and survival. These rocks are not random. Their movements follow invisible gravitational rhythms, controlled by Jupiter's immense pull. In this region, Jupiter's gravity creates what scientists call orbital resonances. These resonances occur when an asteroid's orbital period becomes a simple fraction of Jupiter's orbit, such as 1/2, 1/3, or 2/3. When this happens, Jupiter tugs on the asteroid at the same point in its orbit again and again, slowly increasing its orbital energy. Over time, these repeated gravitational nudges destabilize the asteroid's path, forcing it either inward toward the sun or outward into deep space. These resonances carve empty gaps in the asteroid belt, known as Kirkwood gaps, where very few asteroids exist. Each gap is evidence of Jupiter's long-term gravitational control. Objects pushed inward sometimes become near-Earth asteroids, crossing Earth's orbit and posing potential danger. But far more are pushed outward, removed from the inner solar system entirely. This constant reshaping of asteroid orbits is one of Jupiter's greatest defensive tools. By preventing asteroids from remaining in stable Earth-crossing paths for long periods, Jupiter dramatically reduces the probability of catastrophic collisions. Now journey even farther, beyond Neptune, into the frozen outskirts of the solar system. Here lies the Kuiper Belt, a vast disk of icy remnants extending billions of kilometers from the sun. Beyond that, surrounding the entire solar system like a giant spherical shell, exists the mysterious Oort cloud, a region thought to contain trillions of cometary nuclei. These distant objects are loosely bound to the sun. Passing stars, galactic tides, and even the gravitational pull of the Milky Way itself can disturb them, sending them plunging toward the inner solar system. These are long-period comets, some of which travel for millions of years before making a single visit near the sun. When these comets arrive, Jupiter stands directly in their path. As a comet approaches Jupiter, it enters a gravitational battlefield. Depending on its speed and trajectory, Jupiter may capture it into a short-period orbit, turning it into a Jupiter family comet. Others are flung completely out of the solar system, never to return. Some are pulled into Jupiter's atmosphere and destroyed in spectacular collisions. Each of these outcomes reduces the risk to Earth. Without Jupiter, many of these long-period comets would make repeated close passes near Earth, dramatically increasing the chance of planetary-scale impacts. Computer simulations spanning decades of research, updated continuously up to 2026, reveal astonishing results. When Jupiter is removed from solar system models, Earth experiences impact rates up to 100 times higher. Civilizations ending impacts become common. Mass extinctions occur frequently. Complex life struggles to survive. With Jupiter present, impact rates drop to survivable levels. Extinction events become rare enough to allow evolutionary recovery. This delicate balance may explain why intelligent life has emerged on Earth, while many exoplanetary systems remain hostile to complexity. Now consider the physics behind Jupiter's immense gravitational influence. Gravity is not simply a pulling force. It is the curvature of space-time itself. Jupiter's enormous mass warps space-time around it, creating deep gravitational wells. Objects entering this region experience dramatic changes in velocity and direction. This is the same principle used by spacecraft during gravity assist maneuvers. By passing close to Jupiter, probes like Voyager 1, Voyager 2, Galileo, Juno, and New Horizons gained enormous speed boosts, allowing them to travel far beyond what conventional rocket power could ever achieve. When Voyager 1 and Voyager 2 approached Jupiter in 1979, their trajectories were carefully calculated so that Jupiter's gravity would bend their paths and accelerate them. This single maneuver increased their speeds by tens of thousands of kilometers per hour, sending Voyager 1 toward interstellar space and Voyager 2 toward Saturn, Uranus, and Neptune. Without Jupiter, these legendary missions would never have been possible. This same gravitational physics operates constantly throughout the solar system. Every asteroid, every comet, every fragment of cosmic debris that passes near Jupiter experiences similar forces. Some are accelerated outward and permanently removed from the solar system. Others are captured and forced into stable orbits. And some are pulled inward, colliding with Jupiter itself. Jupiter's immense gravitational well acts like a cosmic trap. Objects entering this region lose orbital energy and spiral inward, ultimately being consumed by the gas giant. These impacts release staggering amounts of energy, often exceeding millions of megatons of TNT. Yet because Jupiter is so massive, it absorbs these collisions without significant damage. Each impact represents a potential disaster that never reached Earth. Jupiter's gravity also stabilizes the orbits of the other giant planets. Its interaction with Saturn creates long-term orbital harmony, preventing chaotic shifts that could destabilize the inner solar system. Without this balance, Earth's orbit could become highly elliptical, causing extreme climate swings that would devastate life. Advanced simulations demonstrate that Jupiter helps regulate Earth's axial tilt. This stability is essential for maintaining predictable seasons, moderate climate cycles, and long-term environmental consistency. Without Jupiter, Earth could experience extreme axial variations, leading to violent climate oscillations capable of triggering frequent mass extinctions. Now consider the role of Jupiter during the early chaotic epochs of solar system history. During planetary migration phases, Jupiter's gravity shepherded enormous quantities of debris outward, clearing much of the material that otherwise would have bombarded the inner planets. This clearing phase likely prevented countless extinction-level impacts during Earth's formative years. As time passed, Jupiter continued to act as a dynamic barrier between Earth and the outer solar system. Each gravitational interaction subtly reshaped the distribution of cosmic debris, constantly minimizing long-term risks. Even today, Jupiter's defensive role is ongoing. High-speed telescopic surveys and space-based observatories regularly detect small objects impacting Jupiter's atmosphere. These flashes of light are signatures of asteroids and comet fragments burning up at incredible velocities. Between 2010 and 2026, dozens of such impacts have been directly observed. Many of these objects were large enough to devastate major cities or even entire regions of Earth. Instead, they were safely intercepted by Jupiter. This continuous stream of impacts proves that Jupiter is not a passive shield. It is an active, dynamic system constantly protecting the inner planets. And as detection technology improves, scientists expect to discover that Jupiter absorbs far more objects than we can currently observe, especially smaller bodies that remain invisible from Earth. In this way, Jupiter functions as the solar system's primary line of defense. Now shift your focus to the modern age, where humanity has finally begun to understand the invisible forces that shape our survival. For thousands of years, Jupiter was simply a bright wandering star in the night sky, worshipped as a god, feared as an omen, and admired as a celestial king. But only in the last few decades have we truly uncovered the immense scale of its power. In 1979, the Voyager spacecraft flew past Jupiter and sent back the first close-up images of its turbulent atmosphere. What scientists saw was beyond imagination. Massive storms larger than Earth. Lightning storms releasing energy thousands of times stronger than terrestrial lightning. And a magnetic field so powerful, it reshaped the surrounding space environment. Jupiter was not merely a planet. It was a cosmic force. But the true revolution began with NASA's Juno mission, which arrived at Jupiter in 2016 and continued transmitting groundbreaking discoveries well into 2026. Juno revealed that beneath Jupiter's colorful cloud tops lies a realm of unimaginable pressure and temperature. Hydrogen gas is compressed into a liquid metallic state, forming an ocean that conducts electricity and generates the strongest planetary magnetic field in the solar system. This magnetic field is so vast that it creates a magnetosphere millions of kilometers wide. If it were visible from Earth, it would appear larger than the sun in the sky. This colossal magnetic bubble deflects charged particles, protects Jupiter's moons, and subtly alters the behavior of cosmic plasma flowing through the solar system. This magnetic field is so vast that it creates a magnetosphere millions of kilometers wide. If it were visible from Earth, it would appear larger than the sun in the sky. This colossal magnetic bubble deflects charged particles, protects Jupiter's moons, and subtly alters the behavior of cosmic plasma flowing through the solar system. Juno also revealed that Jupiter does not possess a traditional solid core. This structure suggests that Jupiter formed through violent early collisions, absorbing massive planetary embryos during its rapid growth phase. This rapid formation is the key to Earth's survival. Because Jupiter grew so quickly, it began clearing debris early, dramatically reducing the intensity of bombardment faced by the inner planets. Without this early intervention, Earth's surface may never have stabilized long enough for oceans, atmosphere, and life to emerge. Using Juno's precise gravity measurements, scientists built ultra-high-resolution models of Jupiter's gravitational field. These simulations, refined continuously through 2026, show that Jupiter's gravitational influence extends far beyond previous estimates. Even objects millions of kilometers away experience subtle but cumulative orbital changes, slowly redirecting them from dangerous trajectories. These findings confirm that Jupiter operates as a long-range gravitational shepherd, guiding small bodies away from Earth-crossing paths long before they ever approach our planet. This knowledge has transformed planetary defense strategies. Modern asteroid deflection techniques directly mimic Jupiter's natural methods. NASA's DART mission in 2022 proved that kinetic impacts can alter asteroid orbits. Future missions plan to combine kinetic impacts, gravity tractors, and ion propulsion systems to achieve controlled orbital modification. In essence, humanity is learning to replicate Jupiter's defensive role on a smaller scale. Jupiter also plays a crucial role in maintaining long-term orbital stability across the solar system. Its gravitational interaction with Saturn creates resonance patterns that stabilize planetary spacing and prevent chaotic orbital drift. Without this dynamic balance, Earth's orbit could become wildly elliptical, triggering catastrophic climate shifts. Advanced simulations demonstrate that without Jupiter, Earth's axial tilt could fluctuate unpredictably. Such instability would generate violent climate oscillations, rapid ice ages, extreme heating periods, and repeated environmental collapses, making complex life nearly impossible. When astronomers study exoplanetary systems, they observe stark contrasts. Systems lacking giant planets exhibit heavy debris bombardment and orbital chaos. Systems containing hot Jupiters, giant planets orbiting close to their stars, often lose inner rocky worlds entirely. Only systems with Jupiter-like giants in distant, stable orbits show conditions favorable for Earth-like planets. Statistical analysis through 2026 suggests that fewer than 1% of planetary systems possess such ideal configurations. This means Earth's long-term habitability may result from one of the rarest cosmic arrangements in the galaxy. Earth's geological history confirms Jupiter's influence. Mass extinction events, though devastating, occur infrequently enough to allow biological recovery. The asteroid impact 66 million years ago that ended the age of dinosaurs created evolutionary opportunity rather than permanent annihilation. Without Jupiter, extinction-level impacts would occur far more often, preventing long-term evolutionary progress. Through modeling, scientists estimate that Jupiter has prevented thousands of civilization-ending impacts over Earth's lifetime. Modern telescopes continuously monitor Jupiter for impact flashes. Each flash represents a cosmic projectile that never reached Earth. Between 2010 and 2026, dozens of such impacts have been directly recorded, many involving objects large enough to devastate entire continents. These observations confirm that Jupiter's guardianship is ongoing. But Jupiter's influence extends even into the distant future. As the sun slowly brightens, Earth's climate will gradually transform. Over billions of years, oceans may evaporate, and surface temperatures will rise. Through all of this, Jupiter will continue stabilizing planetary orbits, maintaining cosmic order long after humanity's time has passed. Yet even Jupiter is not eternal. In roughly 5 billion years, the sun will expand into a red giant, engulfing Mercury, Venus, and possibly Earth. Jupiter's orbit may shift dramatically, reshaping the architecture of the solar system one final time. But until that distant epoch arrives, Jupiter will remain the dominant architect of planetary survival. And this leads to the ultimate question. What would happen if Jupiter had never existed? Now imagine a universe almost identical to ours, except for one catastrophic difference. Jupiter never existed. In this alternate solar system, the outer regions beyond Mars are chaotic, filled with countless fragments of rock, ice, and dwarf planet-sized objects. Without Jupiter's massive gravity to shepherd and eject these bodies, the inner solar system is bombarded relentlessly. The asteroid belt would be far denser, containing perhaps 5 to 10 times its current mass, and large objects, some as big as small planets, would roam freely, destabilizing planetary orbits. Every few million years, Earth would face impacts comparable to or even larger than the one that caused the mass extinction of dinosaurs 66 million years ago. Oceans could boil, atmospheres could be stripped away, and continents would be shattered. Any complex life attempting to evolve would be repeatedly wiped out, leaving only microorganisms to survive in isolated refuges. Long-period comets from the Oort cloud, normally intercepted by Jupiter, would now travel unimpeded toward the inner solar system. Earth would be subjected to regular bombardments by objects tens of kilometers across. Night skies would be lit by fireballs, while massive impacts would reshape the planet's surface and climate repeatedly. Evolution would be in a constant reset mode, and intelligent life would almost certainly never arise. Now imagine human civilization in such a universe. Agriculture would collapse under chaotic climate swings and impact winter events. Civilization would fail to stabilize long enough to develop technology or culture. Any attempt at long-term infrastructure would be destroyed within centuries by cosmic events. In reality, however, Jupiter stands as a massive gravitational shield. Its 318 Earth mass presence acts as a cosmic gatekeeper, bending trajectories, capturing asteroids, and ejecting potential killers into deep space. Every year, Jupiter intercepts multiple objects large enough to destroy entire regions of Earth. Events confirmed by observed impacts in its atmosphere from 2010 through 2026. Jupiter's gravitational influence is amplified by its interaction with Saturn. Together, they maintain long-term stability in the solar system, preventing chaotic shifts in Earth's orbit and helping regulate the planet's axial tilt. This ensures moderate seasons and climate stability, which are essential for life. Observations from NASA's Juno mission, launched in 2011 and providing detailed data through 2026, reveal that Jupiter's core is partially diffuse and metallic hydrogen extends deep into its interior, generating the strongest planetary magnetic field in the solar system. This magnetosphere extends millions of kilometers, deflecting solar wind and charged cosmic particles, indirectly protecting Earth's atmosphere from long-term erosion. Simulations show that Jupiter's influence extends far beyond simple collision prevention. By maintaining orbital resonances and redirecting asteroids from dangerous paths, it has reduced Earth's impact rate by at least an order of magnitude, allowing ecosystems time to recover from natural disasters. The 1994 impact of comet Shoemaker Levy 9 on Jupiter provides a dramatic, real-world example. The comet had been torn into 21 fragments by Jupiter's tidal forces before colliding with the planet. If the comet had not encountered Jupiter, these fragments could have posed a serious threat to Earth centuries later. The event demonstrated that Jupiter acts as a planetary defense system on a massive scale, absorbing impacts that might otherwise have been catastrophic. Even today, Jupiter is active in this protective role. Telescopes and space observatories detect frequent small impacts on the planet, some comparable in energy to millions of megatons of TNT. Each flash of light in Jupiter's atmosphere represents a potential disaster averted. Looking to the future, humanity can learn from Jupiter. Planetary defense strategies such as NASA's DART mission, asteroid tracking by ESA and JAXA, and future gravity assist techniques mirror the natural processes Jupiter has been using for billions of years. With advanced propulsion and orbital manipulation, humans may one day replicate Jupiter's role on a smaller scale, protecting Earth or even other inhabited worlds. Jupiter's existence is a reminder of the fragility and rarity of life in the universe. It is not only a silent guardian, but also a cosmic architect, shaping the destiny of Earth and providing conditions that allowed complex life to emerge. Every swirling storm in its atmosphere, every lightning flash, and every gravitational interaction in the outer solar system is part of a natural defense mechanism that has preserved life on Earth. Without Jupiter, intelligent life on Earth would almost certainly never have arisen. With Jupiter, our planet became a rare oasis of stability in an otherwise hostile cosmic environment. This is the story of survival, of destiny, and of the hidden giant that made life on Earth possible. You are watching Infinite Cosmos.